We're delighted to introduce Ginevra Castellano. She's a professor in intelligent interactive systems and director of the Uppsala Social Robotics Lab, Department of Information Technology, Uppsala University. She's going to be talking to us about trustworthy human-robot interactions, building social robots for good. Please welcome Ginevra Castellano.
Hello, everyone. Thank you very much. And I'm very happy to be here today to talk about social robots. So when family and friends who are not very much acquainted with what I do ask me, so what are social robots? I often forget to take off my scientist hat and reply something like, well, social robots are robots that can interact with people in a way that is socially acceptable, socially intelligent. They resemble humans to some extent. And the reply is usually the following. But are they really useful? Do they do anything good for society? And that is an important question. So today I'm going to talk about trustworthy human-robot interaction and how we can build social robots for good. And I'll give you some examples from my research group's work in different application areas. So I will start talking about social robots in education and give examples of what it means to advance social robots in education. So social robots have been showing interesting and promising results in education. For example, facilitating children's learning of STEM topic, second language learning, or reading, just to name a few. And this, in order to support both teachers and parents in the classroom and at home. And my research group has been working for several years on social robots in education, and we know that social robots can be good and can do good for children's learning. But what is good really, and how can we avoid situations where robots might not do good? So advancing social robots for good means building robots that bring measurable benefits for users, but also identifying and limiting possible negative consequences. And I'll give you examples of this by showing some of my group's work. So in the Animatas projects, in collaboration with colleagues at KTH Royal Institute of Technology and Instituto Superior Técnico Lisbon, we develop robotic storytellers that support primary school children to create story and to develop verbal creativity. And we investigated how an EMIS robot, like the one that you see in this video, can do that by inducing emotions through a collaborative game. And what we found is that when children experience positive emotion during the game, their verbal creativity is higher. Then what we've done, we developed a similar storytelling application, this time with a different robot called Ferhat from Ferhat Robotics. And here we started to ask a different set of questions. So do children trust this kind of robot? Do they build a connection? Do they form a relationship with the robot? Because we know that trust is important for learning, especially in the context where a robot might play the role of a supportive friend or a tutor. And we can make this robot look differently, more human-like to your left, or more machine-like to your right. And what we have found is that children tend to trust the robot, and they even disclose information with it, at least with a robot that is less human-like in the way it looks. But while this trust, this connection, or even intimacy can be good for children's learning in an educational context, we also need to ask ourselves, is there a point at which a social robot can foster too much trust, too much connection, too much intimacy? And this depends, for example, on who controls the robot. It depends on the presence of an adult overseeing the robot use and making judgment calls. It depends on the robot's ability to be transparent and to be clear about what it can and cannot do. It even depends on the data that the robot's dialogue ability are trained with. And while some of these questions are important to ask for any AI and technology for children's application, social robots have a physical body, so a higher agency and higher chance to affect how we humans think and behave. So we really need to make sure that we reflect on possible negative consequences more deeply. Let me give you another scenario. We remain in the education application. So can we use social robots to build more equitable STEM education? So we know that educational outcomes of students from disadvantaged groups are influenced by systems of inequity which arise along lines such as ethnicity, gender, or age. And very human-like robots, like Furhat, enable us to choose characteristics in how a robot looks that cue for social identities like this. So we, as human-robot interaction designer and developer, have a huge responsibility in how we use this feature in a way that is socially harmonious. So in the STEM educational environment, strategies to tackle inequities include, for example, restructuring the learning environment to be more inclusive, to expose kids to more diverse role models. And we think that a more diverse design of how a robot looks has the potential to affect positive social change and to challenge inequities, and at the same time building more trustworthy robots. So we ran a study where we delivered a classroom lectures on the topic of machine learning and algorithmic bias to 9 to 12-year-old kids by using a team of 3 human-like robots while varying the gender and the ethnicity diversity of the teams. And what we found was that the children placed higher trust in the high gender diversity team. So what we can find here is that working with human likeness and in how we choose human-like characteristics for robots presents great opportunities. The opportunities to challenge and to disrupt harmful stereotypes that arise in STEM education. But at the same time, can human likeness also be a double-edged sword? That's also an important question to ask. Well, if used inappropriately, of course, it could also contribute to reinforce harmful norms. It could even end up hurting disadvantaged groups. So again, we as human-robot interaction designer have really a big responsibility in how we work with human likeness in robotics. Now I'm going to move on to a different application and talk about building social robots for good in healthcare, and specifically in mental health care, and how social robots may help supporting the screening of perinatal depression. So let me start with telling you a bit about what perinatal depression is. It is a mental health disorder with high societal costs, which affects as many as 20% of women, either during pregnancy or after childbirth. And in order to receive treatment, a diagnosis is required. But access to skilled personnel varies a lot. Not all women receive the screening. This results in up to 50 to 70% of cases going undetected. So we really want women to be made more aware about perinatal depression, about what it is, about what its risks are. We want more women to be screened and more cases to be detected and treated. So we are asking the following question. Could we use a social robot like Furhat to support both the raising awareness of and screening of perinatal depression? And we address this question by conducting interdisciplinary research of the boundaries of different disciplines, including human-robot interaction, perinatal depression, gender studies, and sociology of law. And by taking this approach, we ran a series of interview studies to gather perspective of different stakeholders on the use of this technology in the context of perinatal depression screening. So we interviewed psychiatrists, we interviewed perinatal depression experts, we interviewed gender studies scholars, and women with previous experience of perinatal depression. And I'm going to show a few examples of the views that some of the women with the previous experience of perinatal depression have shared with us. And you will see that they are quite mixed. So some women feel very positive about social robots playing a role in perinatal depression screening. They think that they themselves would open up more easily with a robot, citing the feeling of avoiding the judgment that they would feel if they were speaking with a human. Other women thought that social robots could play an important role in raising awareness of perinatal depression, both within the medical institution and outside of the medical institution, whenever there's a lack of information, whenever there's a lack of skilled personnel. But robots should be used to assist and not replace clinicians. So that's very important, something that came through very strongly. So at some point in the process, we need to have human oversight. And finally, we also had a group of women who felt quite negative about the social robots in perinatal depression screening, citing fears of feeling abandoned by the healthcare system. And because we see this ambivalence, these different attitudes on the users of the technologies, we need to start to ask important questions. Again, we go back to not only let's think about what are the positive benefits, but are there possible negative consequences? So we need to ask questions such, are there goods in conflict here? So what may be good for a patient might not be good for another one. What may be good for the healthcare system or for the clinicians might not be good for the patient themselves. So how can we think about an ethical design of social robots for perinatal depression screening? How can we make sure that social robots truly support clinicians instead of replacing, of reducing the number of humans? And I'll end with a third application, which is transportation systems, and tell you a bit about our work on autonomous vehicles, and about how can we build trustworthy autonomous vehicles. So in the European-funded SIMAWARE project, we are using participatory design methods to gather people's views on what characteristics autonomous vehicles should have in order to be perceived as trustworthy. So here we refer to the EU ethics guidelines for trustworthy AI, which identify 7 requirements for trustworthy AI. And we're specifically interested in the context of this work on human agency and oversight. And in the following question, so what level of autonomy should the vehicle have? So we ask people. And we ran an online study with over 200 participants where we ask people under different circumstances how much level of autonomy they'd be willing the vehicle to have. And we consider different situations in a highway and in suburban scenarios, asking people to imagine to play the role of a driver. So we had different scenes in these scenarios, and we had role-play-like narrations that would prompt participants to tell us what they would do and how much level of autonomy they would give to a vehicle under a specific situation. So what we found is that participants would trust less and would feel less comfortable in giving a higher level of autonomy to a vehicle in the highway scenario, so potentially a more dangerous one should something unexpected occur. But what's interesting here was that this was the case irrespectively of the level or the amount of information that we provided participants with about the situations. Think, for example, about GPS, about speed, or even more detailed information such as the presence of objects in the surrounding, the distance from them. So this did not seem to matter. Most importantly, we found that the less negative attitudes users have, the more willing they will be or more comforted they will be in giving higher level of autonomy to vehicles and to trust them. So in this work, our participants did not really sit in a physical car, but the questions to be asked here is an important one. So if robots are to free up people's time or relieve effort from humans during driving, how can we make sure that we preserve their human agency? How do we make sure that we preserve human oversight? How do we make sure that we preserve their dignity as individuals? So we think that more research is needed, especially because, as we see from this example, and from the example that I shown about perinatal depression screening, we have many different attitudes from users towards technology. So we really need to ask important questions here about how we can do this right. And to end, so what way forward? So if you truly want to build social robots for the societal good, we need to take a responsible approach and design robots with ethical values in mind. We need to build standards for principle of trustworthy AI that work in practice. So we need to work towards an operationalization of ethics guidelines in specific context. We need to regulate possible negative consequences. We need to have more interdisciplinary discussion with societal stakeholders, like the ones that I have shown in the case of perinatal depression. And finally, we need to ask defining questions about what it means to build robots for good. And that's all from me. And this is work that I have done in collaboration with some of my wonderful PhD students and postdoctoral researchers and collaborators. And if you wish to learn more, please visit the website of the Uppsala Social Robotics Labs. Thank you very much.
Ginevra, I absolutely love that. And I was really interested to hear about the concern that people had with, high danger environments. It reminds me of Elisha Otis, who invented the elevator brake in the early 19th century, early 20th century. And people were always afraid to get into elevators because they weren't used to them working all by themselves. So for the early days of elevators, no one wanted to get in. They wanted someone to operate the elevator. And it kind of reminds me of this fear of once we get used to self-driving cars, I think the fears will probably alleviate as we get more accustomed to it. How much immersion in these sort of environments do you think people need before they say, okay, I completely trust this? So whether it's education or healthcare or self-driving cars, at what point do people go, okay, I'll let the AI do it, do you think?
Well, of course, as you say, it is really important to consider about the fact that potential users need to be exposed to the technology, because talking about the technology, talking about a specific use case is not sufficient to truly understand whether are these attitudes kind of real, or will they change when users interact with the technology? And actually, this is something that we observed in the case of perinatal depression screening. So we had different kinds of sessions with women with previous experience of perinatal depression. So first, we ran a series of interview studies, workshops, where we sort of showed the videos with demos. But then we brought women to our lab, and they actually got to see the robot. Still, of course, the real interaction enriches the experience, but we still saw this kind of ambivalence. So it's really difficult to tell, but of course the expectations may be different if you have not met the technology in the first place.
Yes, and understanding how it works as opposed to actually interacting and seeing it working can have a big effect.
Yeah.
Do we have questions from the floor from Ginevra? Yes, one right here at the front. One moment, we'll get a microphone to you. I will go to here first, and then we'll go to you, if that's okay. Can we get a microphone to this lady? Thank you.
Thank you. Thank you so much for the talk. I'm here. What are specific use cases or scenarios, especially in the scenario with children, where investment in the human-robot interactions outranks human-human interactions, where we know that there is empathy and care and real emotions?
Yes, of course. So I want to be clear here and say that in all our research, we really look to design applications and role for robots so that they don't replace humans, but they actually support different kinds of users in different ways. And for example,
Why?
because I think, we don't want to replace the human contact.
Why not?
Because, of course, we need to ask ourselves, we talked about it yesterday or in several talks, how do we make sure that we use technology in a way that supports us and that we sort of keep our humanity, so we don't lose, some characteristics of what it means to be humans. And we don't want to forget about the importance of human-human relationships.
For sure, but there must be some models in which computer-human interactions or learning is better. I mean, if we look at it from a scientific point of view, because we hear this all day yesterday, we want to make sure the human's in the loop. And I know that's important to some companies from a PR point of view, right? But in reality, are there not some learning scenarios where humans would do much better learning from a computer just adapting to its learning environment?
Well, you could think, for example, of situations where, for example, in the educational context, children would be alone or at home and needing to practice reading. So in that case, we can think about some kind of application where this kind of reading skills can be developed. But in general, we want to make sure to keep some kind of human oversight.
Okay.
And human oversight will play different kinds of roles, clearly.
Okay. Do we have time for this really quickly, this lady here?
My question kind of taps into what you were talking about. I was most interested in all of this presentation on that asterisk about the children. So you found that the children were more willing to disclose to the social robot that looked less human. And so I'm really curious about, and that the women felt like it was easier to talk to that because it wasn't human. And so I'm kind of curious about what that says about the safety that we provide or don't provide to each other. And so I guess I'm kind of curious about what's that sweet spot? Does a robot have to look like a human? Should it look like a human? I think about that. Anybody who's familiar with that Shoggoth picture of what generative AI really is, like, do we do ourselves a disservice by making them look like humans, or should we let them look just as weird as they are? I'm really curious.
A quick response, if you can.
Great question, because this is at the key of the research that we do. So how human-like should robots be? And that is the same for many other kinds of AI-powered technologies. So, how much human likeness, how much does human-like benefits, and how much instead can hurt the interactions? We see examples of both situations. It's very much context-dependent. But in the perinatal depression screening, that clearly is a different examples where, you think about depression, there's a stigma associated with it. So there are several research studies which show that some participants prefer to talk with a machine.
Okay. You guys need to hook up and chat afterwards, because I would love to join that conversation, but I have to introduce our next guest. Ginevra, everyone.
Thank you very much.
Fantastic. Thank you so much.
Thank you.